Okay, good evening, ma'am and sir. We are about to begin our webinar in a few minutes with its series for the National Capacity Building Seminars on Research Writing for Research Consultants. Today is February 2, 2022, and we are very much thankful for the opportunity to be with you all. And for this evening or for this event, I will be your moderator for the rest of our webinar. And I am Sonny Soriano, an academic consultant of Maranatha Christian Academy of School System. And our house rule for this event, please turn off our microphone, may or may not open our camera. If you can open, please open and use your identification or username in our for the recognition of our names. Okay. Mabuhay! Ladies and gentlemen, welcome to Embracing the Culture of Research at Core Educational Research Center. And this event is an initiative of the EdCore Educational Research Center to equip its research consultants with the necessary knowledge and skills in the conduct of research, as well as to enable them to become better research consultants. And this series of webinars is intended for EdCore's research consultants and also open to the public, especially to the students and educators who wish to improve themselves in the field of research writing. And now let us recognize the presence of the following persons. Let us welcome Dr. Richard D. Sanchez, the head of research consultant. Good evening, sir. Dr. Adrian Lawrence P. Carvajal and Dr. Ace Silagman, the National Consultant and the National Deputy Consultant for Research Publications and Trainings. Good evening. And also let us recognize the EdCore's national consultants and the respective chairpersons of each different events, the regional coordinators, our provincial division and city coordinators, and all of you EdCore research consultants who are present in this event. And also, I will not forget our teachers from public school and private schools. You may shout out the name of your institutions for us to recognize you this evening. And to begin our program, let's have an audiovisual presentation for the prayer and for the singing of our Philippine national anthem, Lupang Hinirang.
Bayang mabiliw, pelas ng silanganan, alam ng puso, sa dibdib mo'y buhay. Lupang hinirang, duyan ka ng magiting, sa manlulupi, di ka pasisingin, sa dagat at bundok, sa simoy at sa langit mong bukaw, may nilagang tula at awit sa paglayang minamahal, ang kisag ng watawat mo'y tagumpay na nanginginig, ang bituin at araw niya kailan pa may di magdidinig, lupa ng araw ng walhati pagsinta, buhay ay langit sa piling mo, aming ligaya na pag may mga api, ang mamatay ng dahil sa'yo.
Monica, I just sent you the email with the client
Looking at the
notes.
doc now, but I think it's an older version. Can you send an updated?
Monica,
Walang hanggan ang iyong biyaya.
sa aking pagmula hanggang sa pag-ibig, awitin ko kabutihan ng Diyos. Kahit tapat sa habang buhay, ika'y mabuti magpakailanman, hanggat ako ay nabubuhay, awitin ko ang kabutihan ng Diyos. Ang ibig mo, siyang gabay sa kasakitan, nariyan ka sa gitna ng kaliliman. Ika'y aking kaibigan, o Diyos aking Ama, at ako'y buhay sa kabutihan ng Diyos. Ika'y tapat sa habang buhay, ika'y mabuti magpakailanman, hanggat ako ay nabubuhay, awitin ko ang kabutihan ng Diyos. Ika'y tapat sa habang buhay, ika'y mabuti magpakailanman, hanggat ako'y nabubuhay, awitin ko ang kabutihan ng Diyos. Kailanman di magbabago ang kabutihan mo, kailanman di magbabago ang kabutihan mo. Buong buhay ay iaalay ko lahat para sa'yo. Kailanman di magbabago ang kabutihan mo, kailanman di magbabago ang kabutihan mo, kailanman di magbabago ang kabutihan mo. Buong buhay ay iaalay ko lahat para sa'yo. Kailanman di magbabago ang kabutihan mo.
That's it. And now to welcome us for this event, let us welcome one of the research consultant of the ETCOR, and she is part of the Technological University of the Philippines and also the director of ETEEAP, no other than, let us welcome Dr. Kevien Cabarrubias-Dela Cruz. Please give her.
Thank you, Dr. Sonny Soriano. Greetings to one and all. It gives me immense warmth and great pleasure to grace all of your presence in the interest of the entire ETCOR community. It is truly an honor to deliver the welcome message among the most esteemed individuals who have won accolades in their respective fields. To you, distinguished educators, researchers, faculty, ladies and gentlemen, good evening. In order to assist educators and researchers in improving the quality of research data analysis skills, ETCOR organizes this webinar. We have invited Professor Paul Jan J. Capote, to share his knowledge and experience regarding quantitative data analysis using SPSS software. I would like to express my heartfelt gratitude to all of you who sincerely committed to this event to make it a success. This event would have been impossible without the support of each and everyone present here. This webinar provides a clear evidence that ETCOR has a strong commitment to contribute positively to the development of researchers. I assure you this event will be productive and fruitful for everyone present here. Welcome to this webinar and have a great discussion. Thank you very much. Let me continue, Professor. Dr. Sonny Soriano, may I continue with the oath-taking ceremony?
Later, ma'am.
So much. Welcome once again. Welcome and have a nice day.
Thank you very much, Dr. Kevien de la Cruz, of the Director of ETEEAP of Technological University of the Philippines, Manila. And now, this event is a wonderful opportunity for those who are doing their dissertation and researches, or it could be an action research. And we are very much thankful for the ETCOR for this privilege and opportunity to all of us. And we are very much thankful that we have our guest of honor and speaker for this evening. He is a Instructor I of Polytechnic University of the Philippines, Paranaque City Campus, Paranaque City, Metro Manila, Philippines. Let us welcome our resource speaker for this evening with the topic Quantitative Data Analysis using SPSS. Let us welcome Sir Paul Jan J. Capote. Please give him a virtual clap.
Hello po, good evening po sa lahat. Rinig po ako?
Yes, sir.
Okay. Thank you po, Dr. Sonny Soriano at saka sa team for this evening's event. Thank you din po sa lahat ng nag-attend. I'm a bit nervous. All right. Pwede po maka-share ng screen?
Yes po.
Hello.
Good evening once again. Good evening to all the research consultants of ETCOR. Ang topic po natin this evening is about quantitative data analysis using SPSS. So we'll be doing quantitative data analysis po, and then I just hope na meron din po kayong mga SPSS na installed sa inyong laptop or sa inyong computer, sa desktop. We only have one objective for this lecture series, and that is to perform data analysis in SPSS. So yan po ang pinaka-objective natin ngayon. So magpe-perform lang po tayo ng data analysis, magra-run. Hindi din siya run kasi hindi naman tayo magpe-program, kundi perform ng analysis in the SPSS. And I believe na lahat po tayo na nandito ngayon ay familiar sa SPSS. It's a software. It's an statistical software commonly used sa mga social sciences. To be specific, we will perform data analysis like tests of correlation. So I included these three statistical tests for test of correlation or association, the Pearson product moment correlation, which is a parametric test, and its non-parametric equivalent tests, the Spearman rank order correlation and the Kendall-Stau B. So ito yung mga common na mga statistical analysis or statistical test if we are interested in determining the association, the relation between two quantitative variables. And I will also lecture on regression analysis, particularly sa multiple linear regression. Madami po tayong mga regression analysis, pero common, basic yung ating multiple linear regression. And lastly, we'll have comparison of means. No, I included here these 3 parametric tests, and these tests are common: the paired sample t-test, the independent samples t-test, and the one-way analysis of variance. And their non-parametric equivalence. The Wilcoxon syndrome test, the Mann-Whitney U test, and the Kroskal-Wallis H test. Okay, so ito po yung ating objective for this evening's lecture. And I hope na makover po natin ito lahat kasi I am given 40 to 60 minutes to lecture. And nakapag-lecture na rin ako dati neto sa main campus. Hindi siya kaya ng 3 hours. Mapunta kami ng 3 days para makover yung lahat ng topics na to. Pero let's see lang po kung ano pong ating makakover. Sana maganda yung flow ng lecture. Alright, so I will begin with tests of correlation or association. This Pearson product moment correlation. So ang gagawin po natin ngayon is lecture ko i-discuss ko yung statistical test, tapos yung kanyang mga assumptions, and then magpe-perform tayo ng test mismo doon sa SPSS natin. Okay? So let's have the Pearson product moment correlation. This is a parametric test that is used to measure the strength and direction of association that exists between 2 variables measured on at least an interval scale. So ang purpose po dito sa test na to ay malaman natin yung strength ng association ng dalawang quantitative variables. Strong ba? Very strong, or negligible, or moderate lang yung association ng dalawang variables. And also yung direction, no? Direction kung ano pa nga tawag nun? Kung positive or negative ba yung direction ng ating association. And between 2 variables. So meron tayong dalawang quantitative variables na mini-measure natin yung kanilang strength of association at saka yung direction ng kanilang association. And at least an interval scale. So at least an interval scale, or in short, continuous ang ating variables. Okay? So yung dalawang variables po natin ay measured at continuous scale. No. Continuous scale, it's a measure level of the variables wherein either interval siya or ratio. Kung categorical naman, it's either nominal or ordinal. Okay? So, ito yung mga possible na makita natin pag nag-perform na tayo ng test sa SPSS. And here are the assumptions of this statistical test. Bakit nga ba napaka-importante ng assumptions? Bakit nga ba napaka-importante na ma-satisfy natin yung assumptions ng isang statistical test? The answer to that is to make our result or interpretation valid. Okay? Kasi pag na-violate yung mga major assumptions tapos still niran mo pa rin, nag-perform ka pa rin ng statistical test na yan, you are not giving justice to that statistical test. Parang, sige lang, gamitin ko lang ito kahit may mga nababiolate. So parang, it's an injustice to statistics. Okay, so here are the assumptions of Pearson product moment correlation. First, variables or the two variables should be measured at the interval or ratio level. That is, they are continuous. Kaya hindi po pwede na nominal ang ating variable, hindi rin pwede na ordinal. Okay, like for example, pwede ba gamitin ang Pearson product para ma-determine yung association ng gender sa belief? So, gender, nominal siya, no? Ang belief, depende kung paano mo mini-measure yung belief. Okay? Pero yung gender na yon, it's a nominal variable, so hindi na natin pwedeng gamitin si Pearson product moment correlation. Okay? So, next is, there is a linear relationship between your two variables. And ma-examine natin ito, malalaman natin kung may linear relationship bang ating dalawang variables through visual inspection of the scatter plot. The next is, there should be no significant outliers. Okay, we can perform a test para malaman kung meron bang significant outliers through visual inspection of the box plot. Pwedeng box plot, pwedeng stem and leaf, pwede ding histogram. No? Pero try natin gamitin si box plot. Then the variables should be approximately normally distributed. Okay, and then we will run Shapiro-Wilk normality test. So Shapiro-Wilk, pag unti lang yung ating samples, or we'll use the Kolmogorov-Smirnov if madami yung samples natin. Pero madami ding mga researchers and statisticians ang nagre-recommend ng Shapiro-Wilk. Okay? So yun po yung Pearson product moment correlation at saka yung kanyang mga assumptions na kailangan nating isatisfy bago tayo mag-perform ng mismong test para valid yung result natin. Okay? Dumako naman po tayo doon sa mga non-parametric equivalence ng Pearson product moment correlation. So merong dalawang non-parametric equivalence, yung Spearman rank order correlation and the Kendall-Stauby. Now, what is this Spearman rank order correlation? It's a non-parametric measure of the strength and direction of association that exists between two variables measured on at least an ordinal scale. So bakit nga ba siya na tinawag na non-parametric? So non-parametric siya kasi yung mga major assumptions ay nababiolate or na-violate. Like for example, the assumptions on normality of distribution, that's a major assumption. So pag na-violate yan, kung hindi tayo magta-transform, then we'll use the non-parametric. Now, magiging weak na ba ang study natin if we use non-parametric test? Kasi observation ko to sa aking mga consultations, sa aking mga clients sa statistical analysis. Ayaw nila, nagre-react sila kapag non-parametric na ang ginagamit ko. So may gusto nila na parametric kasi daw maganda siya. Katanggap-tanggap siya sa mga panel. Kasi non-parametric weak daw. So ang non-parametric, magiging kasing strong na siya ng parametric provided na madami kang sample size. So isa yan sa mga requirements, major requirements, para mapantayan ni non-parametric yung parametric niya. So kailangan madaming sample size. Okay? Kasi parametric, powerful talaga siya, powerful na test. Okay, so it determines the degree to which a relationship is monotonic. So a monotonic relationship exists when either the variables increase in value together, or as one variable value increases, the other variable value decreases. So ito po, yung tinutukoy natin na monotonic. So pag nag-increase yung isang variable, mag-increase yung isa. Kung mag-increase, mag-decrease yung isa, vice versa. Okay? Now, mahina naman po ang Spearman kapag may non-monotonicity sa distribution ng data. Okay, yung pangatlong scatter plot natin. So, it shows a non-monotonic distribution. So pag ginamit natin si Spearman dito, weak ang result natin. Parang hindi siya reliable na result, hindi valid yung result. Here are the assumptions. Variables should be measured at the interval or ratio level, or they are continuous. The variables represent paired observations. So kung paired observations po, galing sila sa iisang source lang. Yeah? There is a monotonic relationship between the two variables, and we can visually inspect this monotonicity through a scatter plot. So yun lang yung mga assumptions ni Spearman. Now, the last one is the Kendall-Stauby. It's a non-parametric measure of the strength and direction of association that exists between two variables measured on at least an ordinal scale. So kung napapansin niyo po sa Kendall-Stau at saka sa Kendall-Stau lang pala, in-include na niya yung ordinal scale na measure ng isang variable. No, ordinal, so merong order na, the order sa variables natin ay nagmamatter na. No? So yung mga numbers nagmamatter na siya. It is an alternative to Spearman rank order correlation, especially when you have a small sample size with many tied ranks. Okay? So small sample size, you can use Kendall-Stau as long na itong sample size na to, small sample size na to, meron siyang mga tied ranks. May mga tied ranks. Like for example, doon sa survey mo, meron kang checklist, say less than 3 hours, 3 to 5 hours, 6 to 8 hours, etc. So yun yung tinatawag natin ng mga tied ranks. Merong ranks, kasi measured siya on ordinal scale. So magagamit natin si Kendall-Stau. And here are the assumptions. Variables should be measured at the continuous or ordinal scale. Example, 7-point scale from strongly agree to strongly disagree. Of course, there is a monotonic relationship between the two variables. And ayun lang yung dalawang assumptions ng Kendall-Stauby. All right? So yun po yung tatlong test of correlation or association na i-perform natin sa SPSS. Kaya ngayon dumako po tayo doon sa SPSS. Basing schedule. Okay. I believe po na hindi pa nakikita sa screen yung SPSS.
Not
Yes
yet
po, wala
po.
Okay po. Sige po. Paano ba ito? Stop share. Okay. SPSS, where are you? SPSS. Ayun po. Kita na po ba yung SPSS natin?
Yes po.
Okay po. So ito yung ating SPSS. So meron tayong dalawang views. Variable view. And wherein dito natin ini-encode yung name type with up to measure ng mga variables natin. And then dito natin i-feed or i-input yung mga data points natin or yung ating data set. Okay po. So ngayon i-open ko po yung data, yung fictional data na andun po sa Google Drive, yung sinend ko po sa group chat. Open ko po yung data na fictional data for correlation. Uy, wala. Ano wala? Ano po ba? Nakita na po ba sa screen yung SPSS?
Opo.
Thank you po. So ito po yung ating data. Mga data siya, fictional lang naman to. So data sa isang business, meron tayong beginning salaries, sex of employee, job seniority, age of employee, and so on. So ito po makikita natin sa variable view. And then, ito naman po yung ating mga data points. Isasama ko sana sa lecture yung pag-prepare ng data sa SPSS. Kaso, yung lecture kasi nakafocus sa quantitative data analysis na mismo. So, analysis. So, ano to? Is it safe to assume na alam na ng lahat paano mag-prepare ng data sa SPSS? Kasi kung okay po, and then we'll proceed to analysis po. Okay, so meron po tayong 11 variables dito. And then mamili na lang po siguro tayo ng variables na gusto nating i-test yung association nila, yung relationship nila. Maybe we can have Maybe we can have age of employee and his or her current salary. Kung meron bang association or relation ng age of an employee and his or her current salary. Okay? So we'll make use of these two variables, age of employee and current salary. And dito po sa ating variable view, ang age of employee is measured on scale level. And the current salary is measured on scale level din. Kasi di ba isa sa major assumption ng Pearson product moment correlation ay yung dalawang variables natin ay measured on scale level. Okay? Same din kay Spearman, except for same din kay Kendall-Stowe. Si Kendall-Stowe lang nag-extend pa sa mga ordinal scaled variable. All right? So ang gagawin po natin ngayon is i-test yung mga assumptions natin kung masatisfy niya. So the first assumption sa Pearson product moment correlation is dapat continuous yung variables natin. So here we see that the age of employee and the current salary variables are measured on scale level. So assumption number 1 is satisfied. Assumption number 2, dapat merong linear relationship ng dalawang variables. Alright? Merong linear relationship. So ang gagawin natin is, tingnan natin or gagawa tayo ng scatter plot para ma-visually inspect natin kung meron bang linear relationship. Now here, hindi kailangan na perfect yung linearity ng relationship. Ang importante is yung trend ng mga data points natin follows a linear, follows a line, an imaginary line, a straight line. Alright? So, paano ba gagawa ng scatter plot? Click po natin yung graph. I hope na naka-follow po. Click po natin yung graph and then chart builder. Then click OK. Yan po lalabas sa screen. And then dito po sa baba, meron tayo dito mga iba't ibang klase ng mga graphs. So ang pipiliin po natin dito is si scatter plot or si dot. Okay? And then meron ding madaming types dito ng scatter plot. Piliin lang po natin yung pinaka-basic. And then ang gagawin natin is i-drag lang natin siya. And i-drag po natin yung simple scatter dito sa chart preview. Ayan po. And then lalabas yung x-axis and y-axis. Okay? So yung dalawang variables natin, dito natin ipasok sa mga axes natin. So paano yun, sir? Kailangan ba na specific na ang variable na to kailangan nasa x-axis siya and then yung isa nasa y-axis? It doesn't matter. Ano po? Kasi sa correlational tests, walang independent variable sa kanila. Same, patas lang sila. Walang independent at walang dependent variables. Kasi hindi na measure ng correlation ang causation. Na po? So even if the two variables are highly correlated, it does not imply causation. So ang causation po ay parte na ng regression analysis. Okay? So I hope po na naintindihan niyo yun. So ngayon po i-drag na po natin yung variables natin. Age of employee tsaka current salary. It doesn't matter po kung saan siya mapunta. So let's drag age of employee to x-axis and current salary variable to y-axis. So i-drag lang po natin yan and then click OK para makita natin yung scatter plot. Tingnan po natin. Ay! Ba't hindi nag-appear yung scatter plot sa screen? Nakikita niyo po ba yung scatter plot?
No po.
Hindi po. Baka need mo munang i-stop share, sir. Hindi ko sure.
Sige po. Sige po. Okay. Specific po pala yung napili ko. Sa screen na lang. Okay, screen. Ayun po. Pero yung kanina po sa mga access, nag-appear po siya sa screen nyo?
Yes po.
Okay po. Thank you po. So ito po yung scatter plot natin sa ating dalawang variables. At napapansin po natin, hindi siya or walang linear relationship na makikita dito kasi para siyang nagfo-form ng funnel. Ano po? Para siyang nagfo-form ng funnel. Maybe magiging linear po ito kapag meron tayong tatanggalin na mga data points. Na po. May tatanggalin tayo ng mga data points and then magiging linear na siya. But in this case, hindi na po natin magagamit si Pearson. Magagamit po ba natin si Spearman? Si Spearman kailangan kasi monotonic. So dito ang hirap tingnan kung meron bang monotonic relationship kasi nga nagpa-funnel shape siya. So dikit-dikit dito and then biglang nag-expand. So siguro kung tatanggalin natin itong mga data points na to, magpo-form na siya ng linear relationship. So, sa real world data po, you expect na bihira lang po makakuha ng perfect linear relationship. Bihira lang po iyon. Nakikita lang po natin yung perfect linear relationship sa mga statistics classes. Kasi nga kailangan na ma-perform yung statistical test. Okay? So let's just assume na lang po na merong linear relationship dito nang makaproceed tayo sa ating correlation tests. Okay? So yan po yung sa second assumption natin, dapat merong linear relationship and let's just assume na meron ng linear relationship dito. So next assumption is ba't di ako Pearson. Okay, next assumption po is there should be no significant outliers. Okay, no significant outliers. Ano po ba itong mga outliers? Ang mga outliers are data points in the data set na sobrang layo sa majority ng mga data points. Ano po? Sila parang mga deviants, kumbaga. Mga deviants sila. Okay? At nakakaapekto po sila sa ating correlation coefficient. Kasi po, yung mga outliers natin, hinihila nila yung imaginary line na ginagawa ng Pearson product moment correlation. Okay? So mga deviant points natin, nanghihila yan ng ating imaginary line. So kaya yung naapektuhan yung ating correlation coefficient. Okay po? So kailangan na ma-satisfy natin na walang significant outliers. Although may mga outliers, but not all outliers are significant outliers. Okay? So tingnan po natin sa box plot kung meron tayong mga outliers. Okay? So paano ba tayo makagawa ng box plot? So doon lang po tayo sa analyze. Okay, click po natin analyze. Then descriptive statistics. Sure. Then explore. Okay po, explore natin. So yung ating sorry. Ay tama. I-drag po natin yung ating dalawang variables. Drag po natin sa dependent list. Yung age of employee at current salary. And then, dito po sa statistics, click po natin yan. And then, i-select po natin yung outliers. Okay po. And then, click continue. And then, click natin yung plots. Then, check natin yung histogram. Histogram is for normality test pala. So, sige. Huwag muna natin galawin itong plots. Focus muna tayo doon sa outliers kung meron bang mga outliers. And then, click OK na po. Okay, so meron po tayong result dito. So, huwag na natin pansinin si case processing summary at saka si descriptives. Sa descriptives po, makikita lang natin dito yung mga summary statistics like for variable age of employee, makikita natin yung mean, and then the median, the variance, the standard deviation, and so on. Then same po sa ating current salary na variable. Pero ang interest po natin ay doon sa mga outliers at makikita natin yun dito sa extreme values table. Po. So dito sa extreme values table, andito yung ating dalawang variables, the age of employee and the current salary. And then, naka-specify na dito yung highest extreme value at saka yung lowest extreme values. So for age of employee, merong 5 highest extreme values and lowest extreme values. And then meron po tayo ditong mga case number kasi guide po natin ito para mahanap yung mga extreme values na to. So case number 196, it's considered as an outlier, a significant outlier. Ang value niya is 64.50. No? And then another case, we have 158, 281, 101, 238. Paano ba hanapin itong case number? So doon lang po ito sa ating data view. Okay? Dito po sa data view. Ano nga yun ulit? Like for example, highest yung case number 196. So punta lang po tayo doon sa ating data view. And then hanapin natin si 196. Okay, ito po si 196. At yung age natin sa 196 na case na to is 64.50 and it's a significant outlier. Ano bang ginagawa natin sa mga outliers? So in the real world, so si statistician, or si researcher, tatanggalin niya to. Na po i-remove niya. Bakit natin i-remove? Kasi it's a significant outlier and it's affecting the correlation coefficient or it will affect the correlation coefficient. So na po? Removal of outliers. No, removal of significant outliers. Okay po? So dito natin makikita yung mga case number ng mga outliers natin. Now, if we remove these outliers, then we satisfy that assumption na no significant outliers. Po. And then, next assumption natin ay the variables should be approximately normally distributed. Po, the variables should be approximately normally distributed. We will run Shapiro-Wilk normality test for this assumption. Okay, so dun po sa ating SPSS. So click lang po natin analyze, descriptive statistics, explore, and then i-drag natin yung dalawang variables natin, age of employee and current salary. And then sa statistics, not in statistics but in plots, i-check po natin yung normality plot with tests. And then pwede din natin i-check yung histogram. Pero kahit hindi naka-check ang histogram, malalaman na natin kung normally distributed ba ang ating dalawang variables. So enough na naka-check itong normality plot with tests. And then click continue and click OK. So yun po, result, meron tayong case processing, meron tayong descriptives, the extreme values kasi naka-check siya kanina, hindi natin in-uncheck. And then ito po yung importante, the tests of normality table. So dito makikita natin yung dalawang test of normality, the Kolmogorov-Smirnov and the Shapiro-Wilk. So okay na po si Shapiro-Wilk. Ang importante po dito kay Shapiro-Wilk is yung significant value natin or the so-called p-value or the probability value. Now, the p-value for age of employee is 0.00. The p-value for current salary is 0.00. And since the p-values are less than the alpha level 0.05, therefore, we conclude that these two variables are not approximately normally distributed. So we violate the assumption of normality. At that assumption is a major assumption. Na po? So ulitin ko po, sa Shapiro-Wilk test, tingnan natin yung p-value or the significant values. And then, i-compare natin siya sa alpha level na 0.05. Default kasi yung 0.05 dito sa SPSS. Since the p-values are less than 0.05, we conclude that the variables age of employee and current salary are not approximately normally distributed. Okay po? So para magamit natin si Pearson product, kailangan greater than 0.05 ang significant values. All right? Now, let's just assume na ang mga significant values natin or p-values natin are all greater than 0.05. And so, the distribution is approximately normal. And so, we can run Pearson product moment correlation. Okay? So, ayun po, na-check na natin yung ilang assumptions nga po yun. Four assumptions of Pearson product moment correlation. If we satisfy these assumptions, then we can run the Pearson product moment correlation analysis. So, balik tayo sa SPSS. So, click po natin si Analyze. And then, select that correlate, then select bivariate kasi dalawa yung variables natin, and then i-drag po natin yung dalawang variables natin, si age of employee and the current salary, to the variables box. Okay? And then sa correlation coefficient, check, okay, by default, naka-check na ang Pearson. Okay? Provided that the 4 assumptions of Pearson are satisfied. Kung hindi naman, then we can use the Kendall-Stowe, provided na nasatisfy din natin yung assumptions ng Kendall-Stowe, or we can use the Spearman, provided na nasatisfy din ang assumptions ni Spearman. Okay po? So naka-check na ang ating Pearson dito. So let's just assume na nasatisfy yung 4 assumptions. Then, okay, wala na tayong gagalawin dito sa options. Walang gagalawin sa style and sa bootstrap. Wala na yan. And then naka-check na rin by default ang flag significant correlations. Makikita natin doon yun sa baba. And then click OK. Okay, hanapin lang po natin yung correlation table. Ito po ang ating correlation table. So makikita natin dito yung correlation coefficient. Now, the correlation coefficient of age of employee and current salary is negative 0.146. Negative 0.146. And naka-asterisk, double asterisk, we have here a note. Correlation is significant at the 0.01 level. Two-tailed hypothesis. Kasi yung ating significant value is 0.001, and that is less than 0.05. Therefore, there is a significant the relationship or the association of these two variables is statistically significant at 0.01 level. So ayun po, sa Pearson product moment correlation. So importante po dito na masatisfy natin yung mga assumptions ng tatlong ng mga tests na yon. So if we want to run Pearson product, isatisfy natin yung 4 assumptions. Kung gusto talaga natin na masatisfy yung 4 assumptions, may gagawin tayo. Like for example, kung na-violate na merong mga outliers, itanggalin natin yung mga outliers, provided na meron tayong justification sa pag-remove ng mga data points na yon. Kasi what if yun talaga sa real world, talagang may outliers talaga? Pwede ba nating i-justify na tanggalin yun? Yun ay kung ang panelist natin ay particular sa mga statistical concepts. Kung hindi naman, lusot na. Okay po. So yun po sa tests of correlation. I-satisfy ang assumptions bago natin ma-run or i-perform yung statistical tests. I believe po na yung mga questions later ng sagutan. Kung merong mga questions. Kasi if later na po, then I will proceed now to the multiple linear regression analysis. Okay po, dumako na po tayo ngayon sa multiple linear regression analysis. So i-open ko yung data na fictional data for linear regression. Naka-open na ba siya? Ito ba yun? This is correlation. Okay, naka-open na. Saan ba siya naka-open? Okay. So ito po yung data natin, fictional data para sa next topic natin, yung multiple linear regression. So we have, parang pareho lang sa ano. Wait lang po ha, i-double check ko lang. Oh, I see. Pareho lang. Ngayon ko lang tayo ito napansin. Sige po, let's make use of the same data set. And we'll have that multiple linear regression analysis. Multiple linear. Now let's have multiple linear regression analysis. This is just one of the many regression analysis, and it's common and basic. It's an extension of the simple linear regression analysis. So sa simple linear regression analysis, you only have one independent variable. Dito naman po sa multiple linear, we have more than one independent variables or predictor variables. And this is regression analysis. It addresses causation. So dito natin malalaman sa regression analysis which of the independent variables ang merong significant influence sa dependent variable. Hindi lang yan. Malalaman din natin sa regression analysis yung kung alin sa mga independent variables ang merong mabigat na influence doon sa dependent variable. So dito ipapasok yung mga research problems natin na which of the factors or independent variables yung i-influence sa ating dependent variable. So si correlation, ulitin ko lang po, si correlation hindi niya masasabi, mako-correlate lang niya yung dalawang variables pero hindi niya masasabi which of these two variables yung nagbibigay influence sa isang variable. So correlation lang yon. So si causation is under na siya ng regression analysis. That is why regression is an extension of correlation. Now, it is used to predict the value of a variable based on the value of two or more variables. The variable we want to predict is called the dependent variable or sometimes the outcome variable. The variables we are using to predict the other variables' value are called the independent variables or sometimes the predictor variables. Meron ding ibang mga references na ang dependent variable, other than known siya as outcome variable, tinatawag din siya as regressand. Now, itong sa independent variable naman, other than predictor variable siya, tinatawag din siyang regressor. Siya po, regressor and the regressand. Okay? So saan ba ginagamit si multiple linear regression analysis? We use this to predict the value of a variable based on the value of two or more variables. Kung interested tayo sa modeling, kasi strength siya ng mga regression analysis yung maggagawa ng regression model. Magpe-predict, ito yung hula na nakabase sa statistics, hindi yung hula-hula lang. Po? So isa yun sa mga strengths ng regression. Now, meron din mga assumptions. Hindi ko na-edit. It's not simple linear regression, it should be multiple linear regression analysis. And here are the assumptions. The dependent variable should be measured on a continuous scale. That is, it is either an interval or ratio variable. So yung ating dependent or the outcome or the regressand should be measured on either interval or ratio. In short, continuous yung level of measurement ng ating dependent variable. Next, kasi nga, multiple na to. Pero kung simple linear regression, so there is one independent variable. And these independent variables can be either continuous, kung continuous, interval or ratio, or categorical, either an ordinal or a nominal. So pwede na natin ipasok dito yung mga gender, mga year level ng mga students natin. Like for example, gusto natin malaman kung may influence ba ang year level ng isang bata sa kanyang anong dependent natin? Kanyang IQ? Okay, pwede yun. Gusto natin malaman kung may influence ba ng gender sa IQ level ng bata. So pwede natin gamitin si regression. Provided na ang IQ is measured on continuous level. Tapos yung gender natin, of course, gender is a nominal variable. So, gusto natin malaman kung ordinal. Gusto natin malaman kung yung ano ba tawag na ito? Yung academic rank or professional rank ng isang teacher, teacher 1, teacher 2, teacher 3, master teacher, and so on. Gusto natin malaman kung meron bang influence yun sa kung anong dependent variable natin. So, ganun. Sa PCR ba tawag nun sa depend? Nalimutan ko na yun. Yung merong mga malaman yung mga points, yung point system para sa PBB. So, pwede natin gamitin sa regression provided na masatisfy natin yung mga assumptions niya. Okay po? So, yun. Ang dependent variable measured on continuous level, and then the independent variable either continuous or IPCRF pala. Thank you po. And then ang independent natin is either continuous or categorical. Third assumption, there is independence of observations. That is independence of residuals, and we can use the Durbin-Watson statistic to test this independence of residuals. Next, there needs to be a linear relationship between the dependent variable and each of your dependent variables, and your dependent variable and the independent variables collectively. Of course, this is a multiple linear regression, so kailangan merong linear relationship. Na po. And matitest natin itong assumption na to through scatter plots and the partial regression plots. Number 5, your data needs to show homoscedasticity. So what is this homoscedasticity? The opposite is heteroscedasticity. Homoscedasticity means na ang variances natin ay uniform. Yun. Tuldo. So variances natin ay uniform. So homoscedastic ang ating data. Kapag hindi uniform ang ating variances, like nagpo-funnel shape siya or inverted from nagka-cluster to nag-expand, so heteroscedastic na siya. Or from nag-expand and then nag-cluster, so heteroscedastic pa rin siya. So kailangan na ang data natin homoscedastic. So we can plot unstandardized predicted values against studentized residuals to check this assumption of homoscedasticity. Next, the data must not show multicollinearity. We can do this, we can check this assumption through correlation coefficients, the tolerance or the variance inflation factor values. So what is this multicollinearity? If two of your independent variables are multicollinear, mahihirapan po tayo na i-determine kung alin sa dalawa ang nagbibigay ng influence sa dependent variable. Na po? Ang magandang example po dito is pag nagluluto daw po tayo tapos nilagyan natin it's out of the world na example. Pero sige, para maintindihan natin yung multicollinearity. Pag nagluluto daw tayo, tapos nilagyan natin ng table salt, and then nilagyan natin ng iodized salt pa. So dalawang salt, ano? And then, masyadong maalat yung niluto natin. Na mahirapan tayo mag-determine kung alin sa dalawang salt na yun ang nag-i-influence doon sa pagiging maalat ng ulam. Yun yung multicollinearity. Nakikita natin yung epekto ng mga independent variables, pero ngayon, since yung dalawa or tatlong independent variables are multicollinear, mahirapan tayo mag-determine kung alin sa kanila ang may effect. Sa yun yung multicollinearity. So sabi ng multiple linear regression, dapat walang multicollinearity. Kung ang dalawang variables are multicollinear, pwedeng i-fuse mo sila or tanggalin yung isa. Okay po, yun yung remedy, kumbaga. Next, there should be no significant outliers, high leverage points, or highly influential points. So ano bang ginagawa ng mga outliers? So hinihila nila yung ating regression line. Okay po, kasi sa multiple linear regression, nag-i-estimate tayo ng regression line. Ini-estimate natin yun para makapredict tayo ng ating dependent variable. Kung merong presence ng mga outliers, particularly significant outliers, mahihila yun. No, instead na pag ganito siya, hindi siya masyadong steep yung ating regression line, tapos may mga outliers sa baba, so mangyayari, bababa din yung ating regression line. Kung madami namang outliers sa taas, so hihilain yung ating regression line. Yun po yung epekto ng mga outliers, particularly the significant outliers. At yung mga influential points naman, hinihila din yung slope ng ating regression line. Ano po? And we can perform case-wise diagnostics and Cook's distance. So case-wise diagnostics to check whether we have significant outliers in the data, and Cook's distance to check these high leverage points or highly influential points. So ma-perform natin yan sa SPSS. Next, the residuals or errors are approximately normally distributed. We can perform we can construct a normal QQ plot of the studentized residuals. So yun po yung mga assumptions ng multiple linear regression. So madaming assumptions na kailangan muna nating i-satisfy para valid yung result and interpretation na magagawa natin out from the multiple linear regression analysis. Okay? Now sir, up to what extent na kailangan mag-adhere tayo sa pag-comply sa mga assumptions? Nakadepende na yun sa culture na sinusunod mo. If you are a conservative data analyst or conservative researcher, then adhere to these assumptions. Okay? So ibig sabihin nun, kung merong conservative, meron ding mga liberal. O meron din yun, ganun, merong mga liberal. And then meron ding mga literatures na nagbaback up na, meron mga current literatures na nagbaback up na okay lang na ma-violate ito, okay lang na ma-violate ito. Kasi statistics is growing naman. Hindi naman siya conservative na discipline. Okay, so ngayon po, balik tayo doon sa SPSS at mag-run tayo ng multiple linear regression. All right. So the same data set, fictional data for linear regression. So ngayon po, marami tayo ditong mga variables. Mag-decide tayo kung alin dito yung gusto nating gawing dependent at alin sa mga ito yung ating mga independent variables. Ano po? Pero kailangan yung ma-label natin na dependent variable. Merong justification na dependent talaga siya. Kasi ang nangyayari sa research ngayon, hindi lang ngayon, kundi dati rin. Kahit hindi naman dependent ang isang variable, ginagawang dependent, hindi binibigyan ng justification bakit naging dependent siya. Is it really a dependent variable sa totoong buhay? Or baka ginawa na lang siyang dependent variable. Kaya ganun po. So dapat merong justification na dependent talaga siya at merong justification na independent talaga siya. Okay, so work na yun ng mga panelists. Okay, so sige. Let's make use of the current salary as our dependent variable. Kasi yung current salary natin is dependent naman po, di ba? Sa DepEd, dependent ang salary mo at mga bonuses sa IPCRF. Ano po? So yung current salary naman natin, dependent sa ating, of course, dependent sa ating rank, academic rank. Ano pa? Dependent din siya sa mga achievements. Dependent din ba ang current salary sa age ng employee? Dependent sa misis. Okay. Okay. So let's make use of current salary as our dependent variable. And then, yung mga independent variables natin, sige, i-test natin whether ang sex of employee ay nakaka-influence sa kanyang current salary. Now, ang sex of employee is measured in ordinal level, and that is okay sa multiple linear regression kasi di ba ang independent could be continuous or categorical. Okay, ang ordinal is categorical. So, safe. Job seniority. No, katagalan sa work na, no? So, pwede siya gawing independent and then measured siya ang scale level. Pwede kasi ang independent pwedeng continuous. Age of employee. No, age of employee. Sige, let's make use of this variable as one of our independent variables. The educational level. No po? Baka nag-i-influence din ang educational level sa current salary. Kung PhD or EdD, mas mataas yung current salary compared sa mga masters or yung hindi pa nagma-master. Totoo po ba yun sa totoong buhay? O sige. How about work experience? Sige, try din po natin yung ito lang dami. Actually, pwede siya. Pwedeng work experience, pwede ding employment category, kaso ang dami na ng independent variables. So, ilimit na lang po natin yung ating independent variables sa 5. No, pero sa real world po, basta mabigyan lang ng justification yung number ng independent variables. Fights na siya. Huwag lang siguro madami kasi pag madaming independent variables naman, merong mga literatures na nagsasabi na OA na yung modeling na ginagawa mo. Na parang nahihirapan, nabibigatan na ang regression pag sobrang dami ng independent variable. Ngayon, hindi ko hawak yung literature so hindi ko masabi kung ilan talaga. Okay? Pero 5 is good na, no? Instinct. Okay po. So, current salary is our dependent variable. Ito po importante ito. Sa regression, ang dependent kailangan continuous. Hindi pwede na dependent is categorical. Okay po? So safe tayo sa current salary. And then we'll make use of sex of employee, age of employee, educational level, work experience, and employment category as our independent variables. Now sa sex of employee, naka-code ito, males and females. So nag-code ng 0 para sa male and 1 para sa female. Tapos dito po sa employment category, there are 7 categories: clerical, office trainee, security officer, and so on. Okay po. So isa-isahin natin ito, yung mga assumptions ng multiple linear regression. So merong mga assumptions na maba-violate. Pero let's just assume na satisfied ang assumption. Okay po. So assumption number 1, the dependent variables should be measured on a continuous scale. Let's check. The current salary is measured on scale level. Assumption 1 is satisfied. Assumption number 2, there are 2 or more. Pasa na to kasi lima yung independent natin. Which can be either continuous or categorical. Okay? Pumasa tayo sa assumption 2. Assumption 3, there is independence of observations. That is independence of residuals. Here, we will perform a Durbin-Watson statistic. So paano ba i-perform itong Durbin-Watson? Ano po ito? Hindi ko na makita yung nasa taas ng SPSS ko. Nag-appear na yung may chat. Pasensya na po, hindi kasi ako gumagamit ng Zoom, naka-Google Meet or MS Teams sa mga classes ko. Paano po siya i-remove? Ayun. Okay. So let's check this independence of observation using the Durbin-Watson statistic. I-click po natin yung analyze. And then select regression. Then select linear. Okay. Nilalabas yan. I-drag natin yung mga variables natin. So for dependent, i-drag natin si current salary. Yan. And then our independent variables, we have the sex of employee, the job seniority. Ay no, hindi pala kasama si job seniority. Ano po? Sex of employee, age of employee, educational level, work experience, and employment category. Okay, so we have 5 independent variables. Drag natin sa independent variable na box. The next, i-click po natin sa statistics. Yan. And then, i-check po natin yung Durbin-Watson under the residuals option. Po. Hayaan nyo na lang yung mga naka-default kasi naka-default na yan. So, i-check natin sa Durbin-Watson. Click continue. Click OK. Okay po. Ito ilalabas sa SPSS. Meron tayong table for variables entered, removed. We have table for model summary pero hindi pa tayo interested sa mga yan. Proceed na po tayo doon sa wait. Ay, andito pala sa model summary yung Durbin-Watson. Sorry. Hanapin po natin si Durbin-Watson doon sa model summary table. Kaya nasa dulo siya, last column. And then the now, the Durbin-Watson statistic is 2.029. So, paano po natin yan i-interpret? So, if the Durbin-Watson statistic is close to 2, that means that there is no autocorrelation detected in the sample. No autocorrelation. Kung walang autocorrelation, that means to say, there is independence of observation. So kapag yung Durbin-Watson statistic natin is close to the value 2, then there is no autocorrelation detected in our sample. No autocorrelation means or implies independence of residuals or independence of observation. Now, ang Durbin-Watson statistic po ay magre-range from 0 to 4. 0 to positive 4. Kapag 0 to substantially malayo na sa 2, then there is a positive autocorrelation. If the Durbin-Watson statistic is substantially away from 2 to positive 4, then there is a negative autocorrelation. So ano pong epekto ng mga autocorrelation na yan? So itong mga autocorrelations, for example, if there is a positive autocorrelation, that implies that the values are likely to change in future time periods in the same way or direction that they have in recent past time periods. That means to say, hindi independent yung ating mga logs. Sa time series kasi siya na term. So hindi independent kasi nga naapektuhan. Yung direction ng log ngayon at yung future ay naapektuhan ng mga past directions. So walang independence of observation, di po ba? Now, kung meron namang negative autocorrelation, the values are likely to move in the opposite direction in future time periods compared to how the values have moved in recent past periods. So kabaligtaran ng positive autocorrelation. In short, walang independence of observation. To make the story short, since the Durbin-Watson statistic is 2.029 and it's substantially close to 2, then we conclude that there is no autocorrelation or there is independence of observation or independence of residuals. And we satisfy that assumption number 3. There is independence of observation. Next assumption po natin, and po, number 3, independence. Number 4, there needs to be a linear relationship between the dependent variable and each. So meron tayong 5 independent variable, therefore meron tayong 5 scatter plot na titingnan. Okay po? Or partial regression plots. Okay? And the second one is the dependent variable and the independent variables collectively, sama-sama sila. O, so paano ba natin ma-check itong assumption number 4? So balik po tayo sa SPSS. Yan pa po ba time? Enough time? 7:53 na. Dr. Richard, signal lang po kayo kung paubos na yung time. Okay, so let's check that assumption ng linear. Thank you po sa feedback. Mas great pa po ito kung merong actual talaga yung kayo po mismo nag-perform ng analysis. Kumbaga learning by doing. May naalala pa ako sa learning by doing. Okay po, so let's check that assumption number 4. So i-check po natin yung... Okay, thank you po, Doc Richard. Check po natin si analyze. Then yung regression po natin. Check yung regression. I-check po natin yung linear. And then nakadrag na po yung ating mga variables kasi yung ginawa natin kanina, nakasave na siya kumbaga. And then i-click po natin yung plots. Na po. So lalabas to ngayon. Then i-check po natin yung produce all partial plots. Po, produce all partial plots. And then i-check din natin yung normal probability plot. Okay, so dalawa i-check natin, produce all partial plots and the normal probability plot. So yung produce all partial plots, yun po yung doon natin makikita yung linear relationship ng dependent variable to each independent variable. While itong normal probability plot naman is yung dependent variable and the independent variables collectively. Then click continue, click OK. So proceed na po tayo doon sa plots mismo. Okay. Okay, so we have here charts. So the first chart is the normal PP plot of regression standardized residual. And dito natin makikita yung kung meron bang linear relationship, ng dependent variable to the independent variables collectively. Ano po, sama-sama na yung 5 independent variables natin. So this is a normal PP plot. And then nakikita po natin dito yung diagonal line. Paano po natin to interpret? Ngayon, kasi this is a visual interpretation, possible na maging bias tayo. May kanya-kanya kasi tayong basis or interpretation kapag visual yung interpretation. Pero napapansin natin na yung mga plots natin ay medyo lumalayo sa ating diagonal line. Yan po ay nagsisignal ng walang maayos na linear relationship ng dependent variable tsaka independent variables collectively. Maganda po kapag yung mga plots natin ay close to that diagonal line. The closer, the better, and safe tayo sa assumption number 4. Na po? So bakit kaya itong part na to medyo nagmo-move na siya away from this diagonal line? Tingnan natin yung mga partial plots. Baka merong mga independent variable na hindi linear sa dependent variable. Okay, let's have the partial regression plots. Here we can see the scatter plot of sex of employee and the current salary. So current is our dependent and sex of employee is our independent. Ngayon, meron bang linear relationship dito or linear trend? Wala, ang hirap niyang i-determine kung meron bang linear, pero unang tingin pa lang, wala. Okay? So isa yan. Si sex of employee, isa sa nag-contribute doon sa paglayo sa normal PP plot. Let's check this one. Ang age of employee and the current salary. Wala ring linear relationship. Let's check the educational level and the current salary. Somehow may naaninag tayo na linear, linear trend, pero medyo safe ito. Parang merong linear trend. Okay, and then current salary, merong linear trend, nag-cluster dito sa part na to. Okay, and how about this one? Employment category. Okay ang employment category kasi meron siyang linear trend. Although kalat, pero nakikita naman natin yung merong linear trend. Sa info, nakita natin yung mga partial plots natin at napansin natin na meron talagang mga independent variables na nagko-cause na ma-violate yung linear relationship assumption. Okay po? So pag na-violate yan, ang remedy natin is either i-transform natin yung data para maging linear. Na kung hindi talaga madala ng transformation, then hindi na tayo magpo-proceed. May isa pa. Deletion or removal of data points. So tingnan mo yung check for outliers and then i-remove mo yun and then rerun the test. Kung wala talaga, wag na nating ipilit ang multiple linear regression. Meron pa namang ibang regression analysis. Yun po? So, yun yung gagawin natin. Let's just assume na na-satisfy natin yung assumption number 4. Po? So, next assumption natin is... No. Nako, ba't no? Ay. Next assumption is your data needs to show homoscedasticity or consistency or uniformity ng variance. Okay? So to check this assumption number 5, so gagawin lang po natin is click analyze, click regression, then linear, same pa rin, and then naka-drag na yung mga variables natin. Okay. And then, click plots. Yan. Yung kanina. Siguro i-uncheck na natin yung mga produce all partial para hindi masyadong madami yung lalabas sa result. And then, i-move natin yung Z-pred, standardized predictor. I-move natin to the X box. And then the Z-resid or the standardized residual to the Y box. And then, click continue, click OK. Okay, doon po tayo sa chart. Okay. Ano pong napapansin nyo sa data points dito sa scatter plot natin? So, di ba nagpa-funnel shape siya? Ano po? From here, medyo may point, and then nag-expand, nag-scatter na siya, ano? And then that implies na there is heteroscedasticity in the data. Meaning to say, the variance are not uniform. Another way to examine this is, dapat yung data points natin ay within the -3 to +3 interval. So dito sa x-axis natin, merong lumagpas ng +3. Ano po? Itong mga points na to. Then sa y-axis natin, pasok siya sa -3, pero merong mga data points na lagpas na ng +3. Po, yan din po ay, pag may mga points na lagpas na sa -3 to +3 on both axes, that implies na merong heteroscedasticity, and that is a violation ng number 5 assumption ng multiple linear regression. Po. Yung mga funnel shape din, funnel shape. Kapag merong funnel shape, that implies heteroscedasticity. So imagine nyo lang po na equal talaga yung kalat sila tapos walang nakikitang trend. So yan, nagsisignal yan ng homoscedasticity. Po. Next assumption. Next assumption is the data must not show multicollinearity. Okay? Must not show multicollinearity. So i-check po natin ngayon kung meron ba tayong mga independent variables na multicollinear. So ano ba ang epekto ng multicollinearity? Multicollinearity inflates the variance of coefficients and causes type 2 errors. Or kung merong multicollinearity sa data mo, possible ka na makakommit ng type 2 error. Ano nga po yung type 2 error? That is a false negative. So lalabas sa result mo, possible siya na lalabas na walang effect, walang influence ang independent variable na to, where in fact meron. Okay? Ba't nangyari yun? Because of that multicollinearity in your data. Na po? So, paano ba natin i-check? So, click Analyze, and then Regression, Linear, then nakadrag ng mga variables natin. Click Statistics, and then i-check natin yung Descriptive. I-uncheck na natin itong Durbin-Watson. So, i-check natin ang Descriptives, and then click Continue, click OK. Okay, and then lalabas ng descriptive statistics table, correlations table. Okay. So, pwede natin gamitin ang correlations table to check whether the independent variables are multicollinear or with respect to the dependent variable kung meron ba silang correlation. So, ganito ang gagawin natin. If the correlation coefficient is greater than 0.7, positive 0.7, then that pair of independent variables are multicollinear. Okay, check po natin. So ang current salary is dependent. So dito na tayo sa sex of employee. Sex of employee versus age of employee. So we have a correlation coefficient of 0.052 and that is less than 0.7. Therefore, hindi sila multicollinear. How about sex of employee and educational level? It's negative, so hindi multicollinear. To work experience, hindi multicollinear and hindi multicollinear. So yun yung gagawin natin dito sa correlations table. Another way to check this multicollinearity is running this procedure. Click Analyze, Regression, Linear, then ayan ang mga variables natin. Click Statistics, and then i-check natin ang collinearity diagnostics. Sorry. I-uncheck ko na itong descriptives, estimates, and the model fit. Okay, i-check pa natin yung collinearity diagnostics. Diyan natin makikita yung tolerance value and the variance inflation factor values. Click continue, click OK. Okay, hanapin natin yung coefficients table. Ito po. So sa coefficients table, dito natin makikita yung tolerance value and the variance inflation factor values. Ang guideline po natin is if the VIF is above 4, wala namang above 4 dito, ano po? Less than 4 silang lahat. If above 4, that implies multicollinearity. Sa tolerance naman, kapag ang tolerance value is less than 0.25, that indicates multicollinearity. So ngayon, itong mga tolerance natin, wala namang less than 0.25. Ano po? Lahat sila greater than 0.25. Therefore, using the tolerance value and the variance inflation factor values, we conclude that there is no multicollinearity among the independent variables. Okay? Now, what if more than 4 ang VIF and less than 0.25 ang tolerance? Then we need further investigation. Okay po? If the VIF is higher than 10, sobra na higher than 10, or the tolerance is lower than 0.1, then there is a significant multicollinearity that needs to be corrected. Okay po? So ayan yun. So from here, we conclude that there is no multicollinearity in our data. Okay, and then we proceed to the next assumption. Sir Richard, okay pa po ba?
Sige lang sir, mag-wrap up ka na po ng konti.
Okay po. Thank you po. Almost done na rin po sa multiple linear regression. So, okay lang po ba kung tapusin ko na lang po itong regression? Alright. So next assumption is no significant outliers, high leverage points, or highly influential points. So gagamitin natin si case-wise diagnostics and the Cook's distance. So to check this assumption, this assumption, so click analyze, regression, linear, then ayan ang mga variables natin. Click statistics, i-uncheck ko na yung collinearity diagnostic. I-check natin si case-wise diagnostics. Ano po? So si case-wise diagnostics will help us to determine the significant outliers. And then dito, if the standard deviation is greater than 3 or equal to 3, i-consider na siya ngayon na outlier, significant outliers. So pwede po natin itong gawing 2, kaso masyadong masyadong narrow na. So okay na yung 3 kasi by default na yan. And then continue, then click po natin yung save. And then let's look for that Cook's distance. Po, i-check natin yung Cook's distance na yan para malaman natin kung meron bang mga highly influential points. And then click continue, click OK. Okay, and let's have that case-wise diagnostics table. Okay, so ito po yung mga data points na kino-consider ngayon as significant outliers. Case 2, case 56, case 60 to case 415 and case 415. So hanapin lang po natin itong case number doon sa data view. Okay po? So ang pwede natin gawin sa case-wise, sa mga cases na to na considered as significant outliers, i-remove natin. Provided na meron tayong justification sa pag-remove. Okay po? And depende din sa degree ng study. What I mean is, kung napaka-strict ng study mo, like gumagawa ka ng vaccine, so kailangan mo talaga yung i-remove. Pero kung mga social sciences, mga soft sciences, parang meron ng tolerance dyan. So pwede na siyang wag nang galawin or depende na yung kay researcher. Okay? And then, proceed po tayo dito sa residual statistics table and let's look for that Cook's distance. Now, sa Cook's distance natin, the minimum is 0.0 and the maximum is 0.207 and safe po ito. Kasi ang sabi sa Cook's distance, kapag ang Cook's distance is greater than 1, then considered na yan ngayon na highly influential points. Okay, so 0 to 0.207, safe ito. Therefore, wala tayong highly influential points. Meron tayong mga outliers. Eh, paano naman kung merong influential points? I-remove natin. Apo? Okay. And then, next assumption, last assumption, and then mag-perform na tayo ng multiple linear regression. Hindi pa tayo nag-perform, nag-check pa tayo ng mga assumptions. The residual or the errors are approximately normally distributed. Paano ba natin to gawin? So, gawa tayo ng normal QQ plot of the studentized residuals. Parang nag-appear na siya kanina. Hanapin natin yung normal QQ plot. Normal QQ plot. Normal QQ plot. No. Let's do analyze, regression, linear, and then sa plots natin, you have the okay, nag-appear na pala siya kanina. The normal probability plot. Okay, ito po. Okay, so the residuals. I know this is normal P of regression, standardized residual. Standardized and studentized. Tama. So dito po makikita natin na ayun nga, malayo na siya sa diagonal line. This implies na the residuals are not approximately normally distributed. So mas maganda na mas close sa diagonal line. Okay? So ayun po, na-check na natin yung mga assumptions, 8 assumptions. Ngayon, if we satisfy all these 8 assumptions, then running the multiple linear regression analysis is valid, justified. So paano ba natin i-run? So analyze, regression, linear, and then click statistics. I-uncheck ko na ang case-wise diagnostics. I-check natin itong estimates, itong confidence interval, if interested tayo paggawa ng 95% confidence interval. Then the model fit, the R-squared change, and the descriptives. Okay, click continue, click OK. All right. So doon na tayo sa model summary. Okay, importante itong model summary. Now, dito sa model summary, the R value is 0.845. What is this R value? This is actually the square root of the R square. And this shows the correlation between the observed and predicted values of the DV. Now, in the real world data, I know this is for R square, sorry. Okay. So next we have the R square. The R square is 0.714. Now sa real world data, an R square that is greater than 0.3 is considered a good model. So what is this R square? R square is also known as the coefficient of determination, and dito natin malalaman yung power ng model natin. How strong is our model? So our model is 71.4% na strong siya sa pag-predict ng dependent variable. Apo? So R square, 71.4% of the variation in the dependent variable is accounted or explained by the variation in the independent variable. So around 71% ng dependent variable ang nai-explain ng independent variable natin, yung 5 independent variables. So around 30% ang hindi nai-explain ng independent variable. And that is okay na. Kasi nga sa real world data, minsan nasa 0.3 lang, 0.4 lang. Malabo or napaka-narrow ng chances na makakuha tayo ng R-square na 100%. Diba? Next, we have the adjusted R-square. Alin ba dito yung pipiliin natin, the R-square or the adjusted R-square? So since we only have one model, then we will interpret the R-square. Kasi pinapa-interpret ito. Sinasama siya sa findings, sa study. Okay? Now, we will make use of the adjusted R-square if we have different models. Okay, so yun. And then, ano pa interpret natin dito? The significant F change. Ito. Our significant F change is 0.00 and this is less than the alpha level 0.05. This means to say na the variables that we added are significantly improved the prediction. Then let's have the ANOVA table. Ang importante dito sa ANOVA table is yung significant value or the p-value is 0.00. It's less than 0.05. This implies that our model is a significant model. It's a significant model. So, statistically correct siya na makapredict ng dependent variable natin, yung current salary. Okay, next. Let's have the coefficients table. Ito yung pinaka-importante sa lahat kasi dito natin makukuha yung coefficient ng ating regression equation or the regression model na gagamitin natin. All right. So we have the unstandardized coefficients, B, and the standard error. So itong mga numbers dito under sa B column, ito yung magsisilbing coefficients ng ating regression model or regression equation. So paano ang regression equation natin? So current salary is equal to negative 2,149.414 plus negative 2,646.33 times the sex of employee plus 70.128 times the age of employee plus 732.938 times the educational level of the employee plus negative 119.378 times the work experience of the employee plus 2,710.237 times the employment category of the employee. That is our regression equation. And we will use that regression equation to predict the current salary of our employees. Of an employee, I mean. Hindi our employee. Okay. Na paano pa i-interpret ito? Okay. Holding this, say for example, hindi din siya, it's an unimaginable. Walang sex of employee, walang age of employee, walang educational level ang employee, walang work experience ang employee, walang employment category ang employee. In short, hindi siya employee. Meron siyang current salary na negative 2,149. Deficit pa, no? And that is unimaginable and that is hindi real. No po? Okay, paano natin interpret ang sex of employee? Okay. Now siguro okay. Proceed na lang tayo dito sa standardized coefficients. Dito natin makikita sa standardized coefficients kung alin sa 5 independent variables ang may highest influence sa dependent variable. So dito, alin ba sa kanila ang mas highest? Yung employment category. 0.558. Mas higher siya than the rest of the independent variables. Meaning to say, ang employment category ang may highest influence sa current salary. Followed by the educational level, then the age of employee, then the work experience, and lastly, the sex of employee. Okay, pwede po natin siya isama sa findings ng ating study. And then, let's check if significant ba. So the significant values are less than 0.05. Therefore, these are significant predictors. Oh, so these are significant predictors. Okay, so paano interpret natin? Paano ang interpretation ng multiple linear regression analysis? So, first, kailangan nating isama sa paper ang regression equation. Okay, yung regression equation natin is yung sinabi kanina na formula, no, isasama natin siya sa ating findings. Tapos, i-reflect natin doon that the regression equation or the regression model is a significant predictor or a significant model in predicting the current salary because the p-value in the ANOVA table is less than 0.05. And then, i-reflect din natin yung order, which of the independent variables ang may highest influence sa current salary. And then which of these independent variables or predictors ang significant predictors. So far, nakikita naman natin dito na they are all significant predictors because their p-values are all less than 0.05. Yun po. So yun po yung multiple linear regression analysis. And I believe na magpas na po ako sa time. So sayang hindi natin madidiscuss yung sorry for the term. Hindi na mali-lecture yung paired samples t-test, yung Wilcoxon sign-drunk test, independent samples t-test, the Mann-Whitney U-test, the one-way analysis of variance, and the Cross-Calwales H-test. Ito pa naman yung mga common sa DepEd ng mga researches. Like for example, gusto malaman kung yung treatment ba ay effective sa pag-improve ng academic performance ng mga estudyante. Di ba may mga experimental group and control group. Meron tayong 5 interventions na inintroduce. Which of the 5 ang may talagang influence doon sa academic performance? Ayun po. So, thank you po for pakikinig.
Thank you very much, Sir Paul. Okay, before we have your questions and to be answered by our guest speaker, let's have the oath-taking ceremony. Once again, let's call on Dr. Kevien de la Cruz to lead us for the oath-taking ceremony for our newly appointed research consultant of ETCOR.
Thank you so much, Dr. Sonny Soriano. So let us now witness the outtaking of the new research consultants. May I humbly request that everyone turn on their cameras and microphones. Okay, ma'am and sir, kindly turn on your cameras and microphones. Okay, there you have it. How about the others? Okay, so kindly raise your right hand and repeat after me. I state your name.
I, Susie May Fabular,
Do solemnly and sincerely
do solemnly and sincerely
promise swear and
Promise,
declare,
swear,
Promise, swear, and
declare
declare
that I will truly and faithfully
that I will truly and faithfully
and to the best of my skill,
and to the best of my skill,
knowledge, and abilities
knowledge, and ability,
execute the powers
execute the powers
and trust repose in me
and trust repose on me.
as ETCOR Educational Research Centers stated
as ETCO,
as ETCOR Educational Research Centers
As
centers,
educational research centers,
and take your position.
research consultant,
research consultant.
So help me God.
to help me God.
To help me God.
Congratulations,
Picturean mo ko, be.
research consultants. Thank you very much. And let us continue embracing the culture of research. Doc Sonny?
Thank you very much, Doc Kevien, for leading our oath taking. And now for the oath of acceptance, let's have Dr. Suzy May Rua Fabular, a teacher one from Cagayan de Oro City, Philippines.
Thank you, Dr. Sonny Soriano, for that. Today, February 2, 2022, marks our commitment and responsibility as ETCOR's research consultant to uphold the vision and mission of the institution. Ladies and gentlemen, fellow educators, research consultants, and research enthusiasts, we are gathered here virtually to abide and stand forth in the contribution in improving the society through academic inquiries and realizing to the very aims and goal of serving the Almighty God for His greater glory. My due respect and greetings to the organizers, prime movers, and to those behind the scene, especially to Dr. Richard D. Sanchez, our head research consultant, who has appointed me to give a little speech on this bigger responsibility in the light of this occasion, which is our oath taking. I, Suzy May Roa Fabular, research consultant based in Region 10, Cagayan de Oro City, in behalf of all the research consultants nationwide, shall accept this responsibility with humility, integrity, and objectivity, henceforth be of service to one and all. Being a research consultant was never a vision this year. I have been a research coordinator in our school, but seldom my love for the discipline has never been recognized. True enough, when you are least appreciated in a place where God puts you as a mission, some other people will appreciate you more, your efforts, your skills, as well as your gift, so you can do more to be more for others. Like the Athenian way of caring and helping, I challenge all my fellow research consultants who are here attending our oath taking to use their talent, skills, and powers to do research in the building of others, to do and also love research. There is no little help offered as long as it is within the heart. Ladies and gentlemen, once again, good evening.
Thank you very much, Dr. Suzy May Fabular. And now, let's proceed for the question and answer portion. I have here a set of questions to be answered by our speaker. Okay, first question, sir, is what specific application do we need to download for that specific SPSS po na ginagamit nyo daw po?
Okay po, thank you po Dr. Sonny. Ang SPSS po kasi is kailangan ng subscription. Kailangan po pong magbayad bago siya magamit. And then maganda po kung merong I know this is illegal. Merong crack version ng SPSS. Maganda din po iyon.
Can you
Kaso
share
ang
daw po?
ang mga crack version po hindi kasi siya updated. Maganda pa rin talaga kung may subscription. Kaso may kamahalan po talaga ang subscription ng SPSS.
Yes po. Can you share din daw po about it?
Yes po, yes po. Ano na lang po siguro, i-type ko po yung email ko po para i-email na lang po ako at doon ko po i-send yung yung crack version.
Yes
Okay
po.
po.
Thank you so much po, sir. There is a commendable message po. Great learning daw po having this webinar for ETCOR and for sharing this, Sir Paul, for a wonderful opportunity to learn something new for SPSS, specifically for the research. Any questions po? Possible. I think all of us have learned so much for this, even though na medyo yung iba talagang types of correlation na kailangan gamitin talaga in our research, specifically for those who are taking their masters and dissertation. Yun po ay siguro talaga po magkakaroon tayo ng part 2 as what our research consultant head as advice na magkakaroon po tayo ng part 2. Kaya we better see poster for details for that. Okay po? I think there's no questions po. Okay, there's a part 2 for it. Okay. Let's proceed for the awarding of Certificate of Recognition to our guest speaker. Certificate of Recognition is awarded to Paul John J. Capote, LPT MST-Math, the research consultant of ETCOR Educational Research Center, for his invaluable time and expertise as a research speaker in the series of national capacity building seminars on research writing for research consultants of ETCOR Educational Research Center, held from October 20, 2021 until March 2, 2022, signed by the National Deputy Consultant for Research Publications and Trainings, Dr. Ace C. Lagman, and Dr. Adrian Lawrence P. Carvajal, National Consultant for Research Publication Trainings, and Head Research Consultant, Dr. Richard D. Sanchez. Once again, let's give him a round of applause to Sir Paul John Capote.
Thank you po. Thank you po.
And to have the closing message for this evening, let's call on one of the event co-chairperson of this event, instructor and university special focal for UNIFAST, Ifugao State University, Ifugao, Philippines. Let us welcome Dr. Michele Jaymalin-Dulay.
Good evening, everyone. To the event chairperson who animates the session and keeping everything under control, Sir Sonny. To my co-event chairperson, Madam Kevien, good evening. To our lecturer for tonight's session, Sir Paul John, for your wonderful and thought-provoking presentation. Significantly, I'd like to express my gratitude to all of the 47 participants who are zooming in tonight. Shout out to my graduate students from the Visayas and Luzon region. Hello there. This workshop would have not been as successful if it hadn't been for your involvement. To our ETCOR officials headed by Sir Richard Sanchez for organizing such a timely webinar that enhances our research endeavors, especially those of us in the academe. Indeed, with each research experience, we develop new abilities, learn more about the type of atmosphere we enjoy being in, the parametric, and the monotonic relationship we encounter. Further, it discovers our strength, weaknesses, interests, and tests our drive to continue studying, just as we did tonight with the lesson on what analysis, the correlation, the association we will dive into in our studies and mostly in our lives. In some circumstances, a research experience teaches us that we don't want to do in the future. The assumptions of the variables in our lives. Was it nominal? Was it ordinal? And others. This is a useful learning lesson that we must acknowledge and apply when deciding what to do next. Thus, we cross our fingers that the lessons we embrace tonight will not end here, but rather rekindle our mind-provoking research thinking, and that it motivates us to embrace more and extend more. On behalf of the ETCOR family, let us all embrace the research culture more and more. Once again, good evening, everyone. Sir Sonny, nakamute po kayo yata.
Yes, po. Thank you very much once again, Dr. Michelle, for that message. Once again, thank you very much and congratulations everyone for attending our webinar. And before that, let's have a photo op for all of us. Please open all our cameras. Thank you very much, po.
We have 2 slides here. Okay. For the first slide, please open your camera, please. Hello, my students from the Visayas region. Okay, for the first slide. Smile. 1, 2, 3. Okay, for the slide 2. Okay, 1 again. For the slide 2, 1, 2, smile. Okay.
Once again, thank you very much, all of you, for attending our series of webinar and saying, may God bless us all and keep safe, everyone. Thank you very much, Sir Richard Sanchez, and to our co-chairpersons and to our speaker for this evening. Thank you very much and God bless po.